All right, ladies and gentlemen, what we have in front of us here is lesson number 11.4. After this lesson, you will be able to represent rational numbers as decimals and also decimals as rational numbers. Remember, rational just means fractional. So I'm sure you talked about these terms last year, but again, we're kind of reviewing. So if you can convert a fraction into a decimal and that decimal stops or ends, it's called a terminating decimal. If the fraction converts into a decimal that doesn't ever end, we could call it non-terminating. If the digits repeat and go on forever and ever, we could also call it a repeating decimal. So the two types of decimal that are possible, terminating and repeating. First, we're going to use long division to convert a couple examples, and then we'll look at the calculator to see how the technology makes our life easier. So, if you remember long division, when you read this fraction, it is 3/8, but it also means 3 is being divided by 8. So, when you use the long division symbol, the 3 would have to go inside the box, because you're dividing by 8, okay? In an elementary school, I'm sure when you first started talking about long division, you talked about how this really can't happen because 3 is not large enough. So you probably learned to add the decimal point and some placeholder zeros, and then you probably learned to carry the decimal point up here. I'm going to move all this down because it's a little tight up there. So, because 8 cannot divide into 3, some of you were probably taught to put an X out front. My elementary teacher said put a 0 there because, of course, 0 times 8, you can't get a value that, divides into 3. So when you go through the process, you will still end up with a 3, but then you might have been taught to bring down your 0 with an arrow. Okay, you don't have to draw the arrow, but I'll do it for this example. What you really can do then is take 8 times some number to equal 30. Problem is, nothing perfectly multiplies by 8 to get 30, so we have to come up with something close without going over. If you remember, 8 times 3 is 24. 24 is the closest value we can get to and not go over. So the process is, once you figure that out, 8 times 3 is 24, you'll again subtract. 30 minus 24 is 6, and it means we need to bring down another digit. So now I'm taking 8 times some number to equal 60. Well, 8 times 8 is 64, but that's too big, so I'm going to have to use 8 times 7, which is 56. 60 minus 56 is 4, so I can bring down another placeholder 0. And this time I luck out. 8 times 5 is exactly 40. The reason I know I'm done is because I get a 0 at the bottom of my long division. So this is how I know it is a terminating decimal. I have a 0 remainder at the end when I am done. So I can see that this is a terminating decimal. And I know that the value of 3/8 has a decimal value of 0.375, or we could read that 375 thousandths is equal to 3/8. Now, of course, technology makes our life easier. So if you remember, if you have to work with a fraction, we can type it in as 3ABC8. If you want to convert it to a decimal, you can use the button second PRB and then enter. You should get the answer of 0.375. A quicker way, though, remember, is just type in 3 divided by 8. 3 divided by 8 and then hitting enter will also give you a decimal value by default, if you remember that it's the top number divided by the bottom number. So, moving on to our second example, I want you to convert the fraction 4/9. Well, 4/9, remember, means 4 is being divided by 9. So when you set it up using your long division symbol, the 4 must be in the box. Again, you're dividing by the 9, and that number is much larger, so you're going to need the decimal point and some placeholder zeros. 0 times 9, because again, 9 cannot go into 4, so we can bring this down. And then 9 times some number has to get me really close to 40. Well, 9 times 5 is 45, but that puts me over, so I'm going to have to go 9 times 4, which is 36. And again, the process is to subtract and bring down the next placeholder 0. Well, 9 times 4, again, gets me as close as possible. And at this point, you should start to see some kind of a pattern. Because we keep getting a 4 remainder every time we subtract, this leads us to realize we have a repeating decimal. Repeating decimal will look like this. You will always get the same remainder over and over and over again. And the way we can write up our answer then, remember, is that the fraction 4/9 is going to equal the decimal 0.4, and because the only digit repeating is the 4, I can put a bar over just the 4. So, the calculator, remember, we have some buttons we could press. We could type this in as a fraction and hit second PRB. We could type in 4 divided by 9. Either way, you're going to see the decimal on the calculator being 0.444444. It goes all the way out. And the way we write that answer, remember, is with the repeating bar of 4 over top. So, if you look at the next section, what I did is I gave you some practice problems, and I would like you to convert. So remember, if you have a fraction already, you can put it in as 1 ABC16 and hit second PRB. Or you can simply type in 1 divided by 16, and you can get your decimal values. Down in this section, you're given a decimal, so you want to type it in as you see it, and then please use second PRB to convert those decimals into fractions. So pause the video here, try those problems, and then click play so you can check your answers. Okay, checking answers across the top row here. 1/16 equals 0.0625. 5/6 had a repeating digit of a 3, but not right away. We had an 8 first and then a whole bunch of repeating 3s, so the bar just goes over the 3. 5 equals 3.25, and number 6 equals 0.7. Repeating, again, make sure you have the bar over the 7. The last examples, I did instruct you to use your calculator to hit second PRB, but I don't want you to forget about this option as well. You probably learned this in elementary school. If your decimal has 2 digits, this is the tenths place, this is the hundredths, we could convert it without technology and just say, hey, this is 35 over 100. 35 over 100 does reduce down to 7 over 20. Your calculator is going to spit out the reduced version. But any of these decimals, technically, at least the terminating ones, you can use place value to help convert. So tenths, hundredths, this one goes to the thousandths place, so this would be a correct value, and then reduced would be 11 over 40. And then this one has the whole number 12, and then, the 8. And then see how this is on the tenths place, hundredths place. We could write it as 8 and 12 hundredths, and then the 12 hundredths reduces down to 8 and 3/25. These are a little bit trickier to work on with place values, so again, your best bet is to use second PRB and to be very comfortable with that. So, if you are set with your note sheet, you'll notice that it gets taped into your notebook. Your assignment is going to be page 3 of your packet. Please see me with questions or concerns.